students, so far we have discussed about linear programming with only one objective, either maximizing or minimizing the objective function. In this lecture, I am going to discuss about how to handle a linear programming which has more than one objectives. The topic which I am going to cover is called goal programming, and I will discuss about the formulation of goal programming. In the next lecture, I will solve the problem graphically with the help of software called Desmos. The agenda for this lecture is goal programming, formulation, developing constraint and the goal equations, and developing an objective function with preemptive priorities. What is the meaning of this preemptive? Preemptive means that priority is specified in advance which cannot be sacrificed. The priority of the objective cannot be sacrificed, that is the meaning of preemptive priorities. So, in previous lecture we studied how a variety of quantitative methods that can help managers to make better decisions. Whenever we decide an optimal solution, we utilized a single criterion. Example, maximize the profit, minimize the cost or minimize the time. In this lecture, we discuss techniques that are appropriate for situations in which the decision maker needs to consider multiple criteria in arriving at the overall best decisions. Dear students, in real life, the decision making is not done with only one criteria. So, we may come across multiple criteria. If there are multiple criteria, how to make the decision? That is what we are going to cover in this lecture. I will explain the examples of multiple criteria decision making. For example, consider a company involved in selecting a location for a new manufacturing plant. A company is looking for a new manufacturing plant. The cost of land and construction may vary from location to location. So, one criterion in selecting the best site could be the cost involved in building the plant. So, what we are saying that one of the criteria for choosing the location is the cost of building and the plant. If cost were the sole criterion of interest, management would simply select the location that minimizes land cost plus construction cost. Before making any decision, however, management might also want to consider additional criteria. Apart from cost, they want to consider additional criteria. What are they? Availability of transportation from the plant to the firm's distribution center, attractiveness of the proposed location in terms of hiring and retaining employees, energy cost at the proposed site, and the local taxes also. So, these are the other criteria for choosing a location for constructing a new plant. In such situations, the complexity of the problem increases because one location may be more desirable in terms of one criterion and less desirable in terms of one or more of other criteria. So, we have seen cost is one of the criteria. So, some locations may be good at cost, lesser in cost, but that location may not satisfy other criteria. Example of goal programming formulation. Let us consider a problem facing ABC investment advisors. A client has $80,000 to invest and as an initial strategy would like the investment portfolio restricted to 2 stocks. So, they have $80,000, they are planning to invest in 2 stocks. So, stock number 1 US oil price per share is $25, estimated annual return per share is $3, risk index per share is 0.5. So, another stock is Hub Properties, price per share is $50, estimated annual return per share is $5 and the risk index per share is 0.25. US Oil, which has a return of $3, see this $3 on a share price of $25, provides an annual rate of return of 12%. How we got to 12%? 3 upon 25 multiply 100. So, it is 12%. Whereas, Hub Properties provide an annual rate of return of 10%. So, it is 5 upon 50 multiplied by 100, that is a 10%. The risk index per share 0.5 for US Oil and 0.25 for Hub Properties is a rating investor assigned to measure the relative risk of two investment. Higher the risk index, values imply greater risk. For example, the US Oil is 0.5. So, the US Oil stock is more riskier than the Hub Properties. Hence, ABC judged US Oil to be a riskier investment. By specifying a maximum portfolio risk index, ABC will avoid placing too much of the portfolio in high risk investment. Here that company will not go for investing all the money in US because that is having the higher risk. To illustrate how to use the risk index per share to measure the total portfolio risk, suppose that ABC chooses a portfolio that invests all $80,000 in US Oil, the higher risk but higher return investment. So, how ABC could purchase $80,000 divided by $25, 3,200 shares of US Oil, and the portfolio would have a risk index of 3,200 multiplied by 0.5, 1,600. So, if the company invests all the money in US Oil, the risk is 1,600. Conversely, if ABC purchases no shares of either stock, the portfolio will have no risk but also no return. Thus, the portfolio risk index will vary from 0 least risk to 1,600 most risk. Now, now we will formulate the goal 1. So, ABC's client would like to avoid high risk portfolio. Thus, investing all funds in US Oil would not be desirable. However, the client agreed that an acceptable level of risk would correspond to portfolio with a maximum total risk index of 700. So, that client is agreeing to bear the risk of 700. Thus, considering only risk, one goal is to find a portfolio with a risk index of 700 or less. That is the first goal. What is the first goal? The client says that I can accept the risk index less than or equal to 700. If the risk index goes beyond 700, I am not interested. That is the expectation of the client. Now, we will go for another goal. Why we are talking about goal 2? Because remember, we are talking about goal programming. There may be different goals. So, we have to solve goal 1, then goal 2, goal 3 and so on. So, we have discussed about the goal 1. Now, we will go to the goal 2. It is like a second objective. First objective is that risk should not exceed 700 units. Similarly, we will discuss about the goal 2. So, another goal of the client is to obtain an annual return at least $9,000. This goal can be achieved with a portfolio consisting of 2000 shares of US oil. Suppose if you buy 2000 shares of US oil, what will be the costing? What will be the cost of that? 2000 multiplied by 25, $50,000, and 600 shares of Hub Properties. How much cost will be? 600 multiplied by 50, 30,000. 50,000 plus 30,000, so it is total $80,000. So, out of $80,000, so 200 shares if he invest on US oil and 600 shares in Hub Properties, the annual rate return in this case would be 2000 multiplied by 3 plus 600 multiplied by 5, it is 9,000. Note, however, that the portfolio risk index for this investment strategy would be, if you go for 2000 in US oil, the risk index will be 0.5, plus if you go for 600 units in Hub Properties, the risk index will be 0.25. So, when you multiply, it is 1150. You see that in the previous slide, the goal 1 is it should be less than or 700, but it is going beyond 700, that is 1150. So, this portfolio achieves the annual return goal, but does not satisfy the portfolio risk index goal. Thus, the portfolio selection problem is a multi-criteria decision problem involving two conflicting goals. One dealing with risk that should be less than or equal to 700, one dealing with annual return that should be greater than or equal to $9,000. The goal programming approach was developed precisely for this kind of problem, like two goals which are conflicting. Goal programming can be used to identify a portfolio that comes closest to achieving both goals. So, the goal programming can be used to identify a portfolio that comes closest to achieving both goals. Before applying the methodology, the client must determine which, if either, the goal is more important. So, we have discussed two goals, P1 and P2. So, the client should say which goal is more important for him. Suppose that the client's top priority goal is to restrict the risk. He says the P1 is my first priority, his first priority, that is keeping the portfolio risk index at 700 or less is so important that the client is not willing trade the achievement of this goal for any amount of increase in annual return. As long as the portfolio risk index does not exceed 700, the client seeks the best possible return. Now, I am going to write the priority levels of goals. Based on this statement of priorities, the goals for the problem are as follows. What is the primary goal? Priority level 1, goal 1, find a portfolio that has risk index of 700 or less. Secondary goal, goal 2, find a portfolio that will provide an annual return of at least $9,000. The primary goal is called a priority level 1 goal and the secondary goal is called priority level 2 goal. In goal programming terminology, they are called preemptive priorities, because the decision maker is not willing to sacrifice any amount of achievement of the priority level 1 goal for the lowering priority goal. The portfolio risk index of 700 is the target value for the priority level 1 primary goal, and the annual return of $9,000 is the target value for the priority level 2, that is the secondary goal. So, there is a P1 and P2. P1 is the first priority. So, in P2, when he is achieving P2, he is not willing to sacrifice the P1. So, P1 has to be achieved. P2 need not be achieved, he is willing to sacrifice on P2, but the P1 should not be sacrificed. The difficulty in finding a solution that will achieve these goals is that only $80,000 is available for the investment. As usual, we begin by defining the decision variables. So, decision variable U is the number of shares of US oil purchased, H is the number of shares of hub properties purchased. So, we have to find out, we have to recommend using this $80,000, the client how much shares he should purchase from U and how much shares he should buy from H. Now, developing the constraint and goal equations. Constraints for goal programming problems are handled in the same way as in an ordinary linear programming problem. Here, the one constraint is corresponding to the funds available, because each share of US oil cost $25 and each share of hub properties cost $50. The constraint representing the funds available is 25U plus 50H less than equal to 80,000. To complete the formulation of the model, we must develop a goal equation for each goal. Each share of US oil has a risk index of 0.5 and each share of hub properties has a risk index of 0.25. Therefore, the portfolio risk index is 0.5 U plus 0.25 H. Depending on the value of U and H, the portfolio risk index may be less than or equal to or greater than the target value of 700. Now, I am going to introduce a new variable called deviation variables. So, what will happen? Look at this equation, 0.5 U plus 0.2 H equal to 700 plus D1 plus minus D1 minus. Here the D1 plus, the amount by which the portfolio risk index exceeds the target value. For example, suppose if I write, say this is 700. So, this is upper side, say this is lower side. So, this distance I can call it as D1 plus. So, D1 plus is amount by which the portfolio risk index exceeds the target value of 700. The bottom one is the D1 minus, the amount by which the portfolio risk index is less than the target value of 700. In goal programming, D1 plus and D1 minus are called deviation variables. The purpose of deviation variables is to allow for possibility of not meeting the target value exactly. That means, in case if the D1 has some positive value, we may exceed 700. In case the D1 minus has some positive value, our value may be less than 700. Consider, for example, a portfolio that consists of U equal to 2000 shares of US Oil and H equal to 0 shares of Hub Properties. What will happen? The portfolio risk index will be 0.5 into 2000 plus 0.20, it is 1000 shares. So, 1000 shares, in this shares D1 plus value is 300. Okay. That means, here it is this value of this one is 300. That reflects the fact that the portfolio risk index exceeds the target value by 300 units. Note also, because D1 plus is greater than 0, the value of D1 minus must be 0. So, this value will be 0. It can have only one value, whether D1 plus or D1 minus. For portfolio consisting of U equal to 0 shares of US Oil and H equal to 1000 shares of Hub Properties, the portfolio risk index would be 0.5 into 0 plus 0.25 into 1000, it is 250. In this case, the value of D1 minus is 450. This value is 0. So, D1 minus value equal to 450 and D1 plus is equal to 0, indicating that the solution provides a portfolio risk index of 450 less than the target value of 700. As I told you, suppose this is 700. So, here, so the value of, say, this is D1 minus. So, this value is here 450, here it is called underachievement. In general, the letter D is used for deviation variables in a goal programming model. A superscript of +1 or -1 is used to indicate whether the variable corresponds to a positive or negative deviation from the target value. So, if I say T D1 plus, it is called overachievement, positive deviation. If I write D1 minus, it is called underachievement. If we bring the deviation variables to the left hand side, we can rewrite the goal equation for the primary goal as 0.5 u plus 0.25 h minus D1 plus D1 minus equal to 700. Note that the value on the right hand side of the goal equation is target value of the goal. The left hand side of the goal equation consists of two parts. One part is a function that defines the amount of goal achievement in terms of decision variables, this part, that is this part. The another part is the deviation variables represent the difference between the target value for the goal and the level achieved. Now, we can go for goal equation for the second goal. To develop a goal equation for the secondary goal, we begin by writing a function representing the annual return for the investment. We have seen previously the annual return for stock 1 is 3, for stock 2 is 5. So, it is a 3u plus 5h. Then we defined two deviation variables that represents the amount of over or underachievement of the goal. Doing so, we obtain D2 plus. Why we have written D2 plus? For the second goal. If it is a plus, we know the amount by which the annual return for the portfolio is greater than the target value of 9,000. D2 minus, the amount by which the annual return for the portfolio is less than the target value of $9,000. So, using these two deviation variables, we write the goal equation for goal 2 as 3u plus 5h equal to 9,000 plus D2 plus minus D2 minus. When you bring on the left hand side, it will become 3u plus 5h minus D2 plus D2 minus equal to 9,000. The objective function in a goal programming model calls for minimizing a function of deviation variables. So, in goal programming context, always the objective function will be minimization, minimizing the deviation variables. In the portfolio selection problem, the most important goal denoted P1 is to find a portfolio with the risk index of 700 or less. This problem has only two goals, and the client is unwilling to accept the portfolio risk index greater than 700 to achieve the secondary annual return goal. That means, his first priority is risk index should be less than or equal to 700. For the secondary annual return goal, he may be accepting lesser than his expected target. Therefore, the secondary goal is denoted by P2. As we stated previously, these goal priorities are referred to as preemptive priorities because the satisfaction of higher level goal P1 cannot be traded for the satisfaction of a lower level goal. Goal programming problems with the preemptive priorities are solved by treating level 1 goal, that is a P1, first in the objective function. The idea is to start by finding a solution that comes closest to satisfying the priority level 1 goal. After solving for the goal 1, then we are going for solving goal 2. So, this solution is then modified, which one? Goal 1 solution, by solving problem with an objective function involving only priority level 2 goals. So, we will be solving for goal 1. After achieving goal 1, then we will go for solving goal 2. However, the revision in the solution are permitted only if they do not hinder the achievement of P1 goals. That means, in goal 2, we can achieve the goal 2 without disturbing the solutions of goal 1. In general, solving a goal programming problem with the preemptive priorities involves solving a sequence of linear programs with different objective functions. For example, first we have to solve P1, then we should solve P2. While solving P2, the solution which are obtained for P1 should not be sacrificed. So, P1 goals are considered first, P2 goals are second, and P3 goals are third, and so on. At each stage of the procedure, a revision in the solution is permitted only if it causes no reduction in the achievement of a higher priority level. That means, we have got the solution for P1, we are going to get the solution for P2, but while getting the solution for P2, the solutions of the P1 should not be sacrificed. the number of linear programs that we must solve in sequence to develop the solution to a goal programming problem is determined by the number of priority levels. In our problem, we have two priority P1 and P2. So, we have to solve 2 times. So, one linear program must be solved for each priority levels. We will call the first linear program to solve the priority level 1 and the second linear program to solve the priority level 2 and so on. Each linear program is obtained from the one at the next higher level by changing the objective function and adding a constraint. So, what we will be doing after solving goal 1, when we are going to solve for goal 2, we will change the objective function, then we will add a constraint for the goal 1, that I will explain. We first formulate the objective function for priority level 1 problem. The client stated that the portfolio risk index should not exceed 700. Now, we have to see there are two things, one is overachieving, one is D1 plus, another one is D1 minus. For example, this is 700, assume that this is 700 in a scale. Now, D1 plus and D1 minus, we have to choose which is more important for the client, because this is a risk. Suppose if the value of D1 plus is positive, we are exceeding the 700, so that is not preferable. Suppose the value of D1 minus is positive, that means we are underachieving, our risk is below 700, so that is preferable. So, what is more important here is the overachievement is not desirable. So, our objective function is we should minimize the D1 plus, that is overachievement. Now, I will come back to the point. Is underachieving the target value of 700 a concern? Clearly, the answer is no, because the portfolio risk index value of less than 700 correspond to less risk. Now, is overachieving the target value of 700 a concern? The answer is yes, because the portfolios with higher index greater than 700 corresponds to unacceptable level of risk. So, which is more serious? The D1 plus is serious. If we exceed 700, that is more serious. Thus, the objective function corresponding to the priority level 1 linear program should minimize the value of D1 plus, because we cannot exceed more than 700. So, our objective function is minimizing D1 plus. Okay. Thus, the priority level 1 linear program can now be stated as a P1 problem. What is that? We have to minimize the overachievement, that means the risk index should not exceed 700. The next constraint is funds available constraint, then goal 1 and goal 2, then the decision variable UH D1 plus, D1 minus, D2 plus and D2 minus. So, for this decision problem, we should find the value of U and H. Dear students, in this lecture, I have discussed about example and need for multi-criteria model, and also I have explained how to formulate the constraint and the objective function. In the next lecture, I will explain how to solve the goal programming problem graphically using the software called Desmos. Thank you.